In this video, we will cover specifying load classifications and defining demand factors. In order for a component to be added to a circuit, the component must have an electrical connector. Electrical connectors have several parameters that must be defined in order for Revit to properly calculate loads. There are also several electrical settings that affect the way Revit calculates loads. We'll take a look at how this works. On the Systems ribbon, in the Electrical panel, click the dialog box launcher to open the Electrical Settings dialog, and then switch to the Load Calculations options. There are two options for the apparent load calculation method: sum true load and reactive load, and sum apparent load. Revit defines the true load as the actual power used by the circuit, and the apparent load is the real and reactive power used by the circuit. You can select the option that works best for you, and that method will be used for the entire project. You can also create load classifications and demand factors. In the Load Calculations options, click Load Classifications to open the Load Classifications dialog. Here, you can see the load classification types that have been created in the project. When you select a type, you can see the name, an abbreviation if one has been added, the demand factor, and then the load class for use with spaces. The important thing here is the demand factor. When you expand the drop-down, you can select one of the demand factors that have been created in the project. You can also create new load classification types to meet the needs of your project. I'll click Cancel and then click Demand Factors. In the Demand Factors dialog, you can see all the demand factor types. Let's take a look at how demand factors are defined. I'll click New and then accept the default name and click OK. When defining demand factors, there are three calculation methods that you can use: constant, by quantity, and by load. With constant selected, you can then specify the constant demand factor. You can also choose to add an additional load to the calculated result. When you select by quantity, there are then two calculation options: total at 1% and incrementally for each range. You can also see an example below that. And take note that the example does not correspond to what's been defined in the table. The table is what you use to define the demand factor. Let's take a look at how this works. With total at 1% selected, I'll click the plus button 2 times to add 2 rows to the table. You can then specify the values in the greater than column and the less than or equal to column. For example, I'll input 5 in the first row for less than or equal to, and then I'll enter 10 in the second row. And notice that the greater than column is updating as I'm updating the less than or equal to column. It's also important to note that there are two options here, so greater than and then less than or equal to. So it's important to keep that equal to in mind. For the first row, I'll enter 100% for the demand factor, and the second row I'll enter 65%, and then the third row I'll enter 50. And so what we've done here is actually set up a table that will work for the example that's noted here. And so if there are 2 items, then all the loads will be calculated at 100%. And so 2 items is less than 5, so our demand factor is 100%. And then if 10 items are used, so in this case our second row here is greater than 5 and then less than or equal to 10. And so if 10 items are used, then the demand factor will be 65%. So in other words, depending on the number of items, it'll fall into one of these rows, and then that demand factor will be used for all loads. So that's the important thing to note with total at 1%. When you select incrementally for each range, then it changes. And instead of a demand factor being used for all the loads, it will work incrementally. And so if we have between 0 and 5, those first 5 will use 100%, and then between 6 and 10, those items will use 65%, and then 11 or more will use 50%. You'll also note that this example has changed, and the example here does not correspond to the table. And so what I just explained was based off of the table that we created for the first example. So don't worry about this example updating. It's simply the same one for each option, and just to give you an idea of how that works. So either total at 1% or incrementally. The third calculation method is by load. And by load works very similar. There is a table that you can use to specify the demand factor, and you can either select total at 1% or incrementally for each range. And instead of the quantity of items, we're looking at the load as indicated by the by load calculation method. Okay, once again, you can add additional rows, specify the greater than or the less than or equal to. Once again, pay attention to the fact that this is less than or equal to, so that's a big thing when you're defining these. And then with either of these, you can choose to add an additional load to the calculated result. I will click Cancel to close this dialog, and then click Cancel to close the electrical settings dialog. Lastly, let's take a look at an electrical connector, and those are defined in the family. So I'll select a lighting fixture family and then click Edit Family to open the lighting fixture family in the Family Editor, and then select the electrical connector. In the Properties palette, you can see the system type, and as long as one of the power options are selected, then we have several other options. The important parameters I want to point out are the ones that we've just been covering, and so the load classification, you can associate that to a family parameter. That way you will have a parameter that you can modify in the project. And so if the load classification of the connector was not mapped to a load classification parameter for the family, then you would not be able to modify that. And so if you notice that you're updating parameters in the family and it's not affecting your load, then it's likely because one of the parameters for the electrical connector is not mapped appropriately. You can also see the voltage and the number of poles. In this case, those parameters are not associated, so they will be the constant unless they're updated here in the family. And then there's an apparent load phase 1, 2, and 3. And for this example, the apparent load phase 1 is mapped to the apparent load family parameter. And then there's also a power factor parameter. And so once again, any of those parameters can be associated to family parameters and then modified in either the family or in the project using that family parameter. And so once again, depending on the electrical settings and your electrical connector parameters, that will determine how Revit calculates the loads in your project. In this video, we will cover reviewing space illumination parameters and reviewing lighting fixture light sources. Revit has several built-in parameters that can help you analyze the lighting layouts in your building model. Let's take a look at how this works. Currently, there are not any lighting fixtures placed in this model. When you select a space, you can see that there are several electrical lighting parameters in the Properties palette. Some of these parameters will populate when lighting fixtures are added to the space. For example, the average estimated illumination is calculated by determining the lumens contributed by each fixture at the lighting calculation work plane, and then dividing it by the space's area. If you scroll down in the Properties palette, you can see the area, perimeter, unbounded height, volume, and computational height of the space. And so some of these parameters are used in calculating some of the lighting parameters. Another quick note is that the room cavity ratio will also populate when lighting fixtures are added. The room cavity ratio is calculated by a formula that is 2.5 times the room cavity height times the perimeter divided by the area. And the room cavity height is the lighting calculation luminaire plane minus the lighting calculation work plane. And so instead of throwing out a bunch of these formulas, let's take a look at adding lighting fixtures and seeing how these populate. On the Systems ribbon, in the Electrical panel, click Lighting Fixture. And then expand the Type selector, and let's select the 2x4 120 type. And then in the Contextual ribbon, we'll select Place on Face, and we'll place 2 of the 2x4s in this first exam room. And then let's switch to the 2x2 120 type, and let's place 4 in the next exam room. And then let's select the 1x4 120 type, and we'll place 3 in the next exam room, and then click Modify to end the command. Now when you select a space, you can see that some of these parameters are populating. And once again, the average estimated illumination is based off of the amount of light from each light fixture. And then, as we saw a minute ago in those formulas that I was stating, the lighting calculation work plane affects that along with the reflectance values. And so right now, our lighting calculation work plane is at 2 feet 6 inches. If I change that to 3 feet, you can see that the average estimated illumination increases, because as our lighting calculation work plane gets closer to the lighting fixtures, then you can see that we get more light at that work plane. I'll change it back to 3. There are also reflectance values for the ceiling, the wall, and the floor. So let's say there were tile floors, and I changed the floor reflectance to, let's say, 50%, and you can see that the average estimated illumination increases. If I decrease the reflectance, then the illumination is decreased as well. And so once again, these parameters are all affecting the average estimated illumination. And so you can take a look at different lighting fixtures and see how it's affecting the space. So if we select the next space, we can see the average estimated illumination from the 2x2s. And then similarly, if we select the next space, we can see the average estimated illumination from the 1x4 lighting fixtures. Now, the lumens at the work plane, there's also a calculation that goes into that, and that is the initial intensity multiplied by the light loss factor multiplied by the coefficient of utilization. Now, the first 2 parameters that I mentioned, they are controlled by the lighting fixture type. So if I look at the type properties of the 2x4 light fixture, you can see that there is a light loss factor parameter and an initial intensity parameter. The coefficient of utilization, that is computed based on those reflectance properties that we looked at, as well as the room cavity ratio. And so now hopefully you can see how all those parameters are working together to determine the average estimated illumination. Alright, so just to summarize here, when you look at a space, the average estimated illumination is populating based on the amount of lumens at the lighting calculation work plane. And you can adjust that work plane in order to see the amount of light at that work plane. So let's say if you're working in a school and you want to see the amount of light at the desk level, you'd want to make sure you set that work plane to the desk level. Or in an office, maybe you want to set it at the desk level or the conference room level or whatever it may be. And so you can see how all those parameters work together. It's also critical that the lighting fixtures are placed at the correct height. Here's the lighting calculation luminaire plane. That is the height of the lighting fixtures in the space. And so in this case we have the lighting fixtures at 9 feet, and so that is the lighting calculation luminaire plane. If I select a light fixture and I flip the work plane and then select the space again, you can see that the average estimated illumination changes. And that's because the light fixture is now, it's flipped. It's facing the wrong direction. You may also have light fixtures that are unhosted, and maybe they're placed slightly above the space. And so all those things can go into account and having your average estimated illumination being incorrect. And so you want to make sure that they're placed correctly and that they are in the space. Another thing is we want to make sure that the light source is enabled. And so I'm going to click Edit Family to take a look at this lighting fixture. And you can see that this yellow component here is the light source. And the light source can be controlled right here in the Properties palette. So for example, if I deselect light source and then load the family back into the project, you now see that there's not any light being calculated in this space because we're missing the light source. Another thing that you can use, I'm going to turn the light source back on, and it's changed now because I modified it. But this is really important if you're working with non-hosted light fixtures and the space may not be seeing it. You can use the room calculation point. And when I enable the room calculation point, you can then use this point to control essentially where Revit's going to be looking for that in the space. And so if your light fixture may be slightly above the space, you can enable the room calculation point and have it be found inside the space. So once again, place light fixtures in the space. Revit will calculate the electrical lighting parameters, and it's important that your light source is enabled and is defined correctly, and that your light fixtures are placed appropriately. In this video, we will cover adjusting electrical settings and creating circuit naming schemes. In Revit, there are several electrical settings that affect many aspects of the electrical design process. To access the electrical settings, switch to the Systems ribbon, and then on the electrical panel, click the dialog box launcher. In the Electrical Settings dialog, there are several settings. For an in-depth look at every single setting, take a look at Revit Help. We'll cover some of the important settings you should focus on when setting up your projects. The hidden line settings control the hidden line style and gaps that are used when elements cross underneath one another in your views. In the general settings, you can specify the electrical connector separator. Then you can choose an option for the electrical data style. This controls the format of the electrical data parameter. I'll click OK and then select a lighting fixture. When I scroll down in the Properties palette, you can see the electrical data parameter. Once again, that setting we just looked at affects the formatting of this parameter value. I'll switch back to the Electrical Settings dialog, and then we'll continue on. The Circuit Description parameter specifies the format of the Circuit Description parameter, which is available for wires. Then you can control the circuit naming by phase for phase A, B, and C labels. These values are only used if you specify the circuit naming by phase for a panel. Next, you can control the option used for capitalization for load names. For example, it can be set to from source parameters, or only initial caps, or sentence capitalization, or everything in upper. Next, you can control the circuit sequence. This controls the sequence in which power circuits are created. So if you want to create them by phase or odd then even, you can select one of those options. Or leave it set to numerical and it'll go in numerical order. The circuit rating is the default rating for circuits. So when you create a circuit, it will be a 20 amp circuit by default. And so if you, depending on what project you're working on, you may want to change that to 30 amp or whatever it may be for your project. Similarly, the circuit path offset is the default path offset for circuits. In the angle settings, you can control the angles used for conduit and cable trays. You can select use any angle, and Revit will use any angle that the fitting families can adjust to. You can choose set an angle increment and then specify a specific increment, or you can choose to use specific angles, and then there's a table here and you can select and deselect the angles that are used. So maybe you want to narrow it down to 90 degrees and 45 degree angles, and you could do that here. In the wiring settings, there are several options here. The ambient temperature, that should be the temperature that the wiring will exist at. And then you can control the gap of wiring crossing. So if they cross in a view, what gaps is going to use. And then you can control tick marks and slanted line across tick marks and other options at the bottom for how the wires will appear. Some important ones you should be aware of is the maximum voltage drop for both branch and feeder circuits, and this is the maximum percentage of voltage drop allowed for either branch circuit wiring or feeder circuit wiring. In the wire sizes settings, there are some important settings you need to specify here. This is where you can control the material, the temperature, and the insulation types. And we'll see where these are used more here in a minute. And you can also create new ampacities or delete existing ones that exist in this table. And so when you create a new ampacity, you can specify the ampacity, the wire size, and the diameter. And you can control these for each material, each temperature, and insulation type. In the correction factor settings, you can select a material and temperature and then define correction factors. And once again, you can create new or delete correction factors. And continuing on, in ground conductors, you can select a material and then create a conductor size for various ampacities. And then in the wiring type settings, you can control your wire types. And so many types are controlled in the type properties dialog, but for wires, those are controlled here in the electrical settings dialog. And so when you create a new wire type, you can give it a name, and then you can select a material, a temperature, and an insulation. And these are what were controlled in the wire sizes settings. You can also control the maximum size, the neutral multiplier, whether or not neutral is required, and then for the neutral size you can set it to hot conductor size or unbalanced current. And then the conduit type can be set to steel or non-magnetic. And you can delete wire types as well. For voltage definitions, you can control the voltage definitions that will be used for the distribution systems. And so these are important here because you can control the minimum and maximum values for a voltage definition. So we see several commonly used voltages here, and you can see that, for example, for 480 volt, the min is 460 and the max is 490. So if we have something in that range, it will be used for the 480 volt definition. Then in the distribution system settings, you can modify existing distribution systems or create new distribution systems. Here you can set the phase, it can be single phase or three phase, and the configuration can be Y or delta. And then for single phase distribution systems, it can be 2 or 3 wires, and for 3-phase it can be 3 or 4 wires. Then you can set the line-to-line voltage, and you can select a voltage definition and a line to ground voltage, and once again you can select a voltage definition. And so these are important for circuiting to make sure that your voltage definitions are specified correctly, and then your line-to-line and line-to-ground voltages are specified. Continuing on, there are cable tray settings and conduit settings that are very similar. You can control whether or not to use the annotation scale for single line fittings, and if you do, then you can specify the fitting annotation size, and that can be for both cable tray and conduit. Take note that if this option is selected, it will only affect the use annotation scale parameter for fittings placed after that. So in other words, if you toggle this option on or off, it does not affect existing fittings. You can then control prefixes, suffixes, and separators for both cable tray and conduit. Next, you can control the rise-drop annotation size, and then single line and 2-line rise-drop symbology. And then on the size settings, you can control the size of cable tray and conduit. In the panel schedules options, you can control the spare label and the space label, and these are text fields, and you can enter in whatever value you want. And then you can choose whether or not to include spares in panel totals, and you can choose whether or not to merge multi-poled circuits into a single cell. And lastly, you can create circuit naming schemes. And we'll take a look at this. I'll create new scheme, and here you can add parameters that will be used. So for example, I will select panel and click add parameters, and then I'll select slot index and click add parameters. And down here at the bottom I can see a preview of the value. So this will just be panel right next to slot index. So I'll add a separator, I'll add a slash in there, and now you can see my updated preview here. And I will name this panel and slot index, and then click OK. And then I can use this circuit naming scheme. So as you can see, there are several electrical settings, and you should take a look at those when you are creating your project so that your design will progress as you want it to. In this video, we will cover recognizing the difference between importing and linking Revit models and DWG files. When working in Revit, there are several options for linking and importing various file formats. To see these options, switch to the Insert ribbon. In the Link panel, you can see tools for linking various file formats. Most of them are self-explanatory. Some of them are not. For example, linking topography allows you to link a topography from another Revit model. Decals work with images, and then when linking coordination models, you can link NWD or NWC files. Similarly, when importing files, you have some options for importing. Let's take a look at the difference between importing and linking. In the Import panel, I'll click Import CAD. In the Import Cad Formats dialog, I'll select the ArchLink DWG file, and then you can see several options for importing the file. Current View Only will import only the current view. If you deselect this option, then it will import any 3D data that's in the CAD file. You can then control the colors and the layers. If you were working with another file type, then it would be levels. But in this case, we're working with layers in the DWG file, and you can choose to import all of the layers, only those that are visible, or you can choose to specify, and then a dialog will open and you can choose which ones. I'll select all, and then for import units, I'll select Auto Detect, And then in the positioning dropdown, you can choose the positioning. And we'll touch on this more in a moment. For this example, we'll select center to center, which will place the CAD file, the geometric center of the CAD file at the geometric center of the Revit model. The origin to origin would place the origin at the origin of the Revit model. For this example, we'll select the center to center. And then these last two options are not available for this import, but there are some other options such as correct lines that are slightly off axis. If there are some lines that are slightly off axis, Revit will correct them. Next, I'll select Open and we will import the CAD file. At this point, I can select it, and you can see that there are several options on the contextual ribbon. And one of those is Explode. And so when you have an imported CAD file, you can actually explode it, and then it will be broken down into its various lines and arcs and whatever else may be in that CAD file. And so this is actually not something that you'd want to do, in my opinion, only in special circumstances maybe. But then also when I click or type VV to open up the Visibility Graphic Overrides dialog and switch to the Imported Categories tab, you can see the imported DWG file, and you can see all of the layers that have been imported. And so those are now imported into the project. And you can control the visibility and line graphic overrides here. I'll click Cancel and then click Undo. And next we will link the link the DWG file. So on the Insert ribbon in the Link panel, click Link CAD. And this opens the Link Cad Formats dialog, which looks pretty much exactly the same as the dialog for importing. And so I'll select the same one, the Arch Link DWG file. And then once again, we have the same options here. And I'll select Current View Only, and we'll leave all the options the same. I'll do center to center again. And notice that this time, though, we do have a By Shared Coordinates option. And so when you link CAD files, you can choose to link by shared coordinates. But this time I'll select center to center again, and then click Open. Now, as long as Select Links is enabled, I can select the linked CAD file, and you'll notice that Explode is not available because this is a linked file now. And I can control the shared coordinates, and then if I open up the Visibility Graphic Overrides dialog, I can still control the layers. I can control the visibility and then any graphic overrides that I want to add for the line styles. I can do that. But in this case, the layer they're not imported, so there's a kind of a separation, if you will, since it is linked, and so everything is not imported into your project. And so that is the nice thing about linking, is that it'll maintain a link and not just import everything into your model. Also, if anything updates in the linked CAD file and you save that file, and then when the link reloads, you'll see it here in the Revit model as well. I'll click Undo, and then we will take a look at linking Revit models. So once again, on the Insert ribbon in the Link panel, click Link Revit. And I'll select the archlink.rvt file. And when you're linking Revit models, there's really just one option other than selecting the file, and that's controlling the positioning. Once again, there is a center to center option, and this will place the geometric center of the Revit model at the geometric center of the host Revit model. The internal origin to internal origin option will place the internal origin of the link at the internal origin of the host model. And so this is nice. So in an MEP workflow, you typically want to use either the origin to origin or the project base point to project base point. And the reason is that you can match up those origins, and then you can acquire the shared coordinates. And then you really have 2 points of reference that will be the same between your host model and the linked architectural model. So once again, internal origin will match up those internal origins. And then by shared coordinates will be available as long as the coordinates have been shared. And so in the workflow that I just described, if you link an architectural model and then you acquire the coordinates, it will acquire those shared coordinates. And then if there was a structural model that also had acquired those coordinates, then you could link it by shared coordinates. If they didn't have the same shared coordinates, then you wouldn't be able to use this option. And then the auto project base point to project base point will match up the project base point, just similar to the origin to origin. And then there are manual options for you to manually place it using one of those points. I'll select the internal origin to internal origin and then click Open. And then Revit will read the file and link it in. And you can select it and make adjustments as needed. In this video, we will cover adjusting the position of linked files and managing linked files. When setting up an MEP project, one of the first things you will do is link the architectural model, and then create levels in the host model to match the levels in the linked architectural model. Or you can use the Copy Monitor tool to copy and monitor levels in the linked architectural model. Another thing you'll want to do is pin the linked model so that it doesn't accidentally move. To do that, you first need to select the link. And if you can't select it, then the first thing I would recommend checking is the Select Links selection option. In this case, it's disabled. When I enable it, I can then select the link. With the link selected, I'll drag it to move it. If you accidentally move it, then you may get a warning, which in this case I did because I'm monitoring the levels in the link, but you may not if you weren't, and then you may not know that it moved. In this case, we can select the link and then right-click and use one of the reposition options. And so if you do notice that a linked model has moved, you can use one of these reposition options. This model was linked using the internal origin to internal origin positioning option, and so we can select reposition to internal origin to move it back. Once again, we get a warning stating that the link has moved. If you use the incorrect positioning option, you could also right-click and then reposition it as needed. With the link selected, I'll click Pin in the contextual ribbon to pin the link. Also, be aware that there is a Select Pinned Elements selection option, and since that is disabled, I cannot select the link, so I'll need to enable that along with Select Links so that I can select the linked model. Also, be aware that there is a Revit Links branch in the project browser, and you can see any of your linked Revit models. In this case, we can see the link that we have, and you can right-click the link and access various options. You can also use the Manage Links dialog to manage the link. When you switch to the Manage ribbon, and then in the Manage Project panel, click Manage Links. Here on the Revit tab, you can see any of the Revit, or all of the Revit links that you have. In this case, we just have one. And you can select it and you can unload it. So if you no longer want to see it, but you want to keep the link, you can use unload. And then you can reload it or reload it from another location. I'll click reload. And be aware that if you are working in a Workshared project, you would actually have two unload options. You could unload it just for you, and the option would say unload for me, or you could unload it for all users. And so this is beneficial when you're working with a large project team and maybe only a handful of people need to use the link. If you want to remove the link altogether, you could use the remove option, and then there would be no reload. You can reload. You'd have to use the link Revit tool to relink it. So that's if you wanted to remove it altogether. You can use Add to add additional Revit links while you're in the Manage Links dialog. Continuing on, you can control the reference type, and that can be overlay or attachment. And what this does is it will actually control how the link will appear when the host model is linked to another project. So in this case, what the reference type would do would control how the architectural link would appear when the Manage Links exercise file was linked to another project. When it's set to overlay, it will not appear. So in other words, if somebody links the Manage Links exercise file, then this architectural link would not appear. If it was set to attachment, then it would. And so this is something you need to be aware of when you have a linked architectural model, because the architect would typically have several other models linked to it. For example, they'll likely have the structural model linked, and so if the structural model was linked to the architectural model as an attachment, then you would see it in your model when you linked the architectural model. And so then if you linked the structural model, you would essentially have two of them. Also, you would see that in under Revit links in the project browser, you would see a listing of any other models that were set to attachment. They would appear underneath there. Additionally, you can control the path type. So when it's set to relative, then it's going to be looking in the same folder as your host model, or if it's set to absolute, then it's looking for an absolute file path. Okay, I'll click OK to close the Manage Links dialog, and we'll wrap up by discussing shared coordinates. So as mentioned, this model was linked using the internal origin to internal origin positioning option, and then to match up the shared coordinates, we can acquire those coordinates. And you can use the tool on the Manage ribbon in the Project Location panel, and then expand the Coordinates button and select Acquire Coordinates. And then, with the tool active, you simply select the link that you want to acquire the coordinates from. In this case, we get a dialog stating that the Acquire Coordinates process was successful. And so I'll click Close, and now at this point the internal origins match and the shared coordinate systems match. And so that will help keep things aligned as the project progresses and will help during coordination. And so it's always important to be aware of the positioning and the coordinates that are being used. In this video, we will cover working in Workshared Projects and using worksharing features. In order for multiple users to work in the same model simultaneously, worksharing must be enabled. To enable worksharing, switch to the Collaborate ribbon, and then in the Manage Collaboration panel, click Collaborate. When enabling worksharing, there are two options, and this is essentially where the central model is saved. You can select within your network or in BIM 360 Document Management. For this example, select within your network and then click OK. Revit then enables worksharing. This is a process that consists of creating worksets and adding any existing components to those worksets. For example, when you click Worksets, the Worksets dialog opens and you can see the two default worksets that are created: Shared Levels and Grids and Workset 1. I'll click OK, and then I'll select a lighting fixture. When I scroll down in the Properties palette, you can see a workset parameter under Identity Data. Any model element created in the project now will be assigned to a workset. Now, before we continue on too far, the next step is to save this current project as a central model. And so when you are working in a Workshared project, you actually need to work in a local file and then synchronize your changes to the central model. But at this point, you'll notice that the Synchronize tools are not available. And in the Quick Access toolbar, when you click Save, you'll get a dialog stating that this is the first time that the project has been saved since work sharing was enabled. And this project will now become the central model. And so if you want to proceed, click Yes. And then Revit will save the current project as a central model. Now, as I mentioned before, you don't want to work in the central model. You want to create a local model and then synchronize your changes back to the central model. So I will click File, Close, so we can close the central model, and then I'll click Open, and in the exercise files, I will navigate to the central model that we just created. Now, the work sharing options are available in the Open dialog. Notice that Create New Local is selected by default. This will create a local copy of the central model, and it will save it in the location specified in the Options dialog. You could also select Detach from Central if you wanted to create a file and detach it from the central model. You could then save that as a new central model if you wanted to, or there are other options that you can choose. I'll select Create New Local and then click Open. Once again, this will create a local copy of the central model and save it in the location that I have specified in the Options dialog. It will also append my Revit username at the end of the file name, and that can be specified in the Options dialog as well. At this point, you can work just like you would in a Revit project. You can model components, lighting fixtures, electrical fixtures, create circuits, whatever you need to do, and then synchronize those changes back to the central model. We can do that on the Collaborate ribbon and use one of the options in the Synchronize panel. So we'll discuss that here in just a second, but once again, there are work sets, and any model element you create will be added to the active work set. So in this case, will be added to work set 1. You can also use the gray inactive work sets option, and when toggled on, any elements not belonging to the active work set will be dimmed. And then when you add components, you can synchronize to central in order to save them back to the central model. And so on the Collaborate ribbon in the Synchronize panel, the Synchronize with Central tool is actually a split button. So I'll select Synchronize and modify Settings. And this opens the Synchronize with Central dialog. You'll want to pay attention to the options under After Synchronizing. And these are all the options that you can relinquish. And in this case, we only have one, which is User Created Work Sets. So I'll select that and then click OK. At this point, I'm synchronizing with the central model, and it's relinquishing anything that I chose in that dialog. If I open the dialog again, you'll notice that none of these options are available because I just synchronized and I relinquished everything. And so you'll want to make sure that those options are selected, and then afterwards you can use the Synchronize Now option, and it will use the settings that you have specified. I'll click Cancel, and then we'll look at the other two tools in the Synchronize panel. Reload Latest will update your local model with any changes or anything that's been added to the central model, but it will not publish your changes back to the central model. Relinquish All Mine will relinquish your ownership of work sets and any borrowed elements that have not been changed. And so you won't be able to close your file, or well, I should say it's not recommended that you close your file when maintaining ownership of components. And so Relinquish All Mine is a way to relinquish everything if you just want to close the model. And during the synchronization process, you will save your changes to the central model, and it will also relinquish your ownership of work sets and elements, and then it will also reload the latest. So Synchronize with Central will essentially do both of these, as well as a few saves in there. Additionally, when you're working in a Workshared project, you can use the Worksharing display modes. When you click Worksharing Display in the View control bar, you can see that there are 4 Worksharing display modes. And you can also adjust the Worksharing display settings. I'll select Worksets, and then the components in the view will be color-coded based on their workset. If you use one of the other options, then they'd be color-coded based on the checkout status, who owns the elements, or components that have been updated. In this case, we're color-coded by worksets. The other thing that's nice about the Worksharing display modes is that when you hover over a component, it shows you the current owner, who it was originally created by, and who last updated it in the central model, as well as anybody that's currently requesting it. So once again, the Worksharing display modes are very helpful when you're working in a Workshared project. In this video, we will cover specifying export setup options and exporting to various file formats. When working in Revit, you may need to export to various file types for use in other programs. Let's take a look at the available options. When you click the File tab and then hover over Export, you can see the various export tools. You can export to various Cad formats, such as DWG or DGN files. You can also export to DWF or DWFX files. Notice that some of these options are unavailable. For example, with FBX, you will export an FBX file for use in 3ds Max, and that needs to be a 3D view. So for example, when I open the 3D electrical view and then go back to the Export FBX option, it's now available. You can also open a family file and then export all of the family types to a text file. You can also export to a GBXML file, create an IFC model, or an ODBC database. You can also export images and animations. This is useful for exporting renderings to images or exporting walkthroughs. When you hover over Reports, you can see that there are 2 options: Schedule and Room Area Report. I'll open the lighting fixture schedule and then go back to File, Export, Reports, and now Schedule is available. And when you select Schedule, you can export a schedule to a delimited text file. You can then import that text file into Excel, and then you can further manipulate the data in Excel. I'll click Cancel and then switch back to the ground floor electrical plan view. I'll go back to the export options, and at the very bottom there's actually options. You can control the options for exporting to DWG and DXF files. There are options for DGN files, and you can also control how models will be exported to IFC. Select Export Setups DWG DXF. In this dialog, you can control how the Revit views will be exported to DWG files for use in AutoCAD. There are several options here, and you should take a look at these options if you're exporting to CAD files often. To begin with, on the Layers tab, you can control how the Revit categories will be exported to AutoCAD layers. Let's take a look at this drop-down at the top. To begin with, you can control how any overrides will be exported. So the categories will be exported to a layer, and then there are overrides that need to be controlled. The first option is to export category properties by layer and then overrides by entity. Or you can choose to not even export those overrides. And so the overrides that we're talking about here are the graphic overrides. So if you have filters and you're controlling certain objects, the graphics of certain objects by a filter, then those overrides can be exported, or you can choose for them not to be exported. You can also choose for those overrides to be exported as a new layer. And then after that, you can choose the layers and then the color ID and how those Revit categories will correspond to those. There are certain standards that you can use. So for example, you can use the AIA standard, and then you can see the layers and color ID for each category. And you can make adjustments as needed. Next, on the Lines tab, you can control the line styles and how those will be exported. You can control the patterns, which is similar to the lines, and then also the text and fonts and how those Revit text will be exported to the DWG file. On the Colors tab, you have three options for how colors are exported. You can choose to use index color, or you can choose to use those specified in the object styles, which is the true color RGB values, or you can choose for those that are specified in the view, which once again are the true color RGB values. I'll leave it set to index colors, and then on the Solids tab, you can control how solids will be exported to the DWG file when you're exporting 3D views. You can choose Polymesh or ACIS solids. And I'd recommend that you do a couple tests there and see which option is going to work best for you. On the Units and Coordinates tab, you can control the units and coordinates, obviously. For the units, you can choose an option for one DWG unit is either a foot, an inch, a meter, centimeter, or a millimeter. And then you can control the coordinate base, which can either be based on the shared coordinates or the internal origin. And so this is extremely important when you're dealing with coordination and everybody's exporting to CAD to take a look in CAD. Then you want to make sure that that's correct and that everybody is using the same option. On the General tab, there are various options. For example, you can choose to export rooms, spaces, and areas as polylines, and then you can choose to hide certain things such as scope boxes or reference planes. And then at the bottom, you can choose the file format. And so that's something important to pay attention to. Be aware that you can create a new export setup and then save that. You can save those options, and then we'll see how that can be used. I'll click OK to close the dialog, and then I'll click the File tab and select Export, Cad Formats, DWG. And then the first option at the top is Select Export Setup. So when you create a new export setup with all of your customized options, you can then select it here. And then you can choose the views or sheets that you want to export. And you can also save a setup here, where it's actually called a set. So you can select various views and sheets, select those, and then create a set if you're going to be exporting those on a regular basis. Or you can simply choose current view or sheet only, and then click Next, and then you can control the naming convention and choose whether or not you want to export views on sheets and links as external references. And then click OK to export the DWG file. In this video, we will cover running interference checks and reviewing interferences. When working in Revit, it's important that you coordinate with other disciplines, others on your team, and even yourself. You can do this by running interference checks. Let's take a look at how this works. On the Collaborate ribbon, in the Coordinate panel, expand the Interference Check button and select Run Interference Check. In the Interference Check dialog, there are essentially two sides. You can select categories of elements on the left and choose to run an interference check between the categories of elements that you select on the right. The first thing you can do is choose categories from, and this can either be the current project or any linked Revit model. I'll select Current Project on the left, and then once again on the right you can either select Current Project or any linked Revit model. I'll select Current Project again, and then on the left I'll select Electrical Equipment, Electrical Fixtures, and Lighting Devices and Lighting Fixtures. And then on the right I'll select Air Terminals, Duct Fittings, and Ducts. And we can run an interference check between these categories of elements. You can also use the buttons at the bottom to help you narrow down your selections. Once you are ready to run the interference check, click OK, and then Revit will run the interference check. When complete, an interference report will appear. To begin, you can choose how you want to group the clashes. Category 1 are the categories that you selected on the left, and Category 2 are those that you selected on the right. So if we select Category 1, we are grouping them based on the electrical categories that we selected. And in this case, we only have clashes between lighting fixtures. I'll select Category 2 and then Category 1. That way we can have a listing for each lighting fixture. Now, when you select a clash grouping, first off, it'll highlight in the model if it's visible in that view, or you can expand that listing and then see the specific elements. And you can see the category of element, the type, the mark, and also the element ID. And once again, if it is visible in the model, then it will highlight. For example, this one is highlighted here. If it's not visible, you can click Show, and then Revit will either zoom into it in the current view or open a view if it's not currently visible. Once again, you can expand it, select individual components, and then you can also leave this interference report dialog open and then work with components in the model. So for example, I'll select the lighting fixture and I can manipulate it just like I would normally in Revit. In this case, I just have this dialog open. So what I will do is I will select the lighting fixture, and then in the contextual ribbon, I'll click Selection Box. And then I will type CE to zoom to extents, and then I can orbit around here and see the clash that we have here. So in this case, I can see the flex duct that's coming in and going right through the lighting fixture. Now I will switch back to first off I want to check the orientation here and then switch back to the floor plan view. And now typically the lighting fixture would have priority, but for sake of example we will move this, move it 2 feet down, and then we'll switch back to the 3D view and we can see that we've resolved this clash here. Now when you are resolving clashes, you can click Refresh in the interference report, and Revit will rerun the interference check based on the same categories of elements that were selected. And now in this case we can see that one of our clashes was resolved and we can continue working. You can also click Close to close the interference report, and then if you want to see the same interference report, go back to the Collaborate ribbon, and in the Coordinate panel, expand the Interference Check button and select Show Last Report. And then that last interference report will open again. For this example, I'll click Close, and then we'll run another interference check. So I'll select Run Interference Check, and then this time I will select Electrical Equipment and Electrical Fixtures. And then on the right, I'm going to select categories from the linked architectural model, and we'll select Walls. And then I'll click OK. Now I have another interference report, and I can see all of the, once again, I can choose how I'm going to group it, so I'll change it back to category 1, and then I can see all the electrical fixtures that are clashing with walls. Now in some cases this may be fine, so let me select one and click Show, and sometimes it really doesn't help you much if it zooms way out. But in some cases we have electrical fixtures that are actually placed on walls, and so depending on how it's placed you may get a clash for that instance, and so that may be fine and you'll just ignore it. But as you can see, you can run interference checks between items in your model, and then you can also run them between items in your model and any linked models. We'll run one more, and this time I'm going to select electrical equipment and electrical fixtures, and then we'll clash it between lighting devices and lighting fixtures, and I'll click OK. And if there are no interferences detected, you will get a dialog stating that with an emphatic exclamation point there, because that's great news when we get this dialog. So run interference checks, resolve those clashes, and then hopefully you can get this dialog. In this video, we will cover specifying coordination settings and copying and monitoring elements. In some projects, the architect controls the location of certain components, such as lighting fixtures. In Revit, you can use the Copy Monitor tools to help with this workflow. Let's take a look at how this works. On the Collaborate ribbon, in the Coordinate panel, you can expand the Copy Monitor button to see the Copy Monitor tools. But first, click Coordination Settings. In the Coordination Settings dialog, you can control how the components are copied from the architectural model, or really from any linked Revit model. In the Apply Settings to dropdown, you can choose any linked Revit model, or you can select New Links for these settings to apply to any new linked Revit models. Select the architectural link for this example. Next, you can choose one of the categories that is available in the Copy Monitor process. Select Lighting Fixtures. Then, in the Behavior area, you can control the copy behavior and the mapping behavior. For the copy behavior, you can choose to allow batch copy, to copy individually, or to ignore the category. Allow batch copy will allow all of the components belonging to that category to be copied at once when the batch copy tool is used. If you select copy individually, then you can select those components individually in order to copy them. Or you can select Ignore Category, and that category will be ignored during the Copy Monitor process. For this example, select Allow Batch Copy. Next, you can control the mapping behavior, which can be set to Copy Original, which will copy the original family type, or you can choose to specify Type Mapping. When Specify Type Mapping is selected, then a Type Mapping option appears below the category name. Then a table is populated in the Behavior area. And you can see there's two columns, in Linked Model, and you can see the families and types that are in the architectural model, and then in the host model you can control the type mapping. Copy Original Type is the default setting, but you can expand the drop-down and then select a family type that is loaded into your host project. So what this allows you to do is essentially copy the location of the lighting fixtures or whatever component you're working with, and then place your custom family in that location. And then Revit will still monitor that location. You can also choose to not copy that type. And then when you have one of the rows selected, you can select linked type or host type to open up the type properties dialog for that specific type. For this example, switch back to lighting fixtures and then set the mapping behavior to copy original. And then click Save and Close. Now, in order to copy and monitor components, switch to the Collaborate ribbon, and then in the Coordinate panel, expand the Copy Monitor button, and you can choose either to select the link or to use the current project. For this example, click Select Link, and then select the linked architectural model. When you do, Revit goes into Copy Monitor mode, and there are several options in the Tools panel of the contextual ribbon. When you click Options, the Copy Monitor Options dialog opens. Now it's important to understand that in this dialog you can control the settings for levels, grids, columns, walls, and floors, whereas in the Coordination Settings dialog there were settings for various categories of elements. And so you can copy and monitor both, and on the MEP side you'll typically get into this dialog to look at the settings for levels or grids. So you can also copy and monitor levels and then specify a type to use based on the types that are in the architectural model. I'll click Cancel, and then you'll also notice that the coordination settings can be accessed here as well. Then you can select Copy in order to copy components individually. So if any of them were set to for copy individually, then you would use the Copy tool. You can also choose to establish a monitoring relationship, and you would use the Monitor tool here. For this example, we'll use Batch Copy since we set lighting fixtures to allow batch copy. Click Batch Copy, and then a Fixtures Found dialog appears, and Revit is simply asking if we want to specify the type mapping behavior before we do this. And since we already looked at that, click Copy the Fixtures. Revit will then begin the process of copying the lighting fixtures from the architectural model into the host model. And depending on the size of the project and the number of components, that will determine how long this takes. So once it finishes, you can hover over the components and see that they are now in the host model. And you can continue copying components. For this example, click Finish. Once again, the components are now placed in the host model. And when you select one of those components, you can see that there is a monitor icon that appears. So that means that the component in the host model is monitoring a component in the link. If you wish to discontinue this, you can click Stop Monitoring in the contextual ribbon. If there's an update in the architectural model, in other words, if one of these monitored components moved, then you will see a warning. And also if it moves in the host model, for example, if I nudge it to the right, then a warning will appear. And it says that there's a coordination monitor alert. So then we can perform a coordination review. So on the Collaborate ribbon in the Coordinate panel, expand Coordination Review, and click Select Link. And then select the linked architectural model, and the Coordination Review dialog appears. And any changes will appear in this dialog. And as you can see, here is one listing for the relative position of two fixtures has changed. And when I expand that listing, I can see the elements that are in question here, where there is a difference. And in the action column, I can expand the drop-down and I can choose to postpone any action, or I can simply reject it, or I can accept the difference. And lastly, I can choose to move the instance in the host model. So if I move this to the side, I'll select Move Instance and then click Apply, and then the fixture in the host model updates to match that in the link. And so once again, if there is a change in the architectural model or in the host model, you'll need to perform a coordination review to get those matched up. In this video, we will cover controlling design options in linked Revit models and using design options. Design options allow you to model various design alternatives in a single Revit project. Typically, architects use design options on a regular basis, and for that reason, it's important to understand how to control design options in a linked architectural model. Let's take a look at how this works. In this linked Revit model, there is a design option set with 3 design options. I'll type VV to open the Visibility Graphic Overrides dialog, and then switch to the Revit Links tab. For the architectural link, I'll select By Host View to open the RVT Link Display Settings dialog. As you can see, there is a Design Options tab. When design options are enabled, there's a Design Options tab in the Visibility Graphic Overrides dialog. And similarly, when you have a linked Revit model, there's a Design Options tab in this dialog. I'll select Custom and then switch to the Design Options tab. And I will select Custom here as well. In the Design Options Set column, you can see any of the design option sets that have been added to the link. And then in the Design Option column, you can choose the design option that you want to display in this view. For example, I'll select Option 2 and then click OK, and then click OK again. Now you can see an additional room that has been added in the linked architectural model. So, if you are working with an architect that is using design options, it's important that you communicate with them to understand which design option they are using if they're still using design options when it comes to the MEP consultant being brought on to the project. In some cases, they may want you to also model maybe a lighting layout in their design options. So we'll take a look at how that works in the host model as well. Switch to the Manage ribbon, and then in the Design Options panel, you can see the Design Options tools. Click Design Options to open the Design Options dialog. Here you can create new option sets and new design options. Under Option Set, I'll click New to create a new option set. And then in a set, you can create multiple design options. Under Option, I'll click New twice so that we have 3 design options to match the linked architectural model. Once you have different options, you can choose to make one a primary, and then you can accept the primary for the option set to make that the main model. For this example, I'll select Option 2, and then under Edit, I'll click Edit Selected. And then I'll close the Design Options dialog. At this point, everything on the screen has become dimmed, and I'm currently working on Option 2, which is the active design option. Additionally, I cannot select other model elements. I can select some of the view-specific elements such as tags, but I can't select any of the others because Active Only is selected. If you deselect Active Only, then you can select other elements. I'll select a lighting fixture and then select Create Similar. And we can place a few lighting fixtures here in this new room. to show how this works. And we'll copy, and we'll copy it one more time just to create a quick little layout here. And so now I've added these lighting fixtures to option 2. Now if I switch to option 3, those lighting fixtures go away because they are a part of design option 2. If I wish, I can go to option 2 and I can copy these to the clipboard. And then I can go to option 3, and on the modify ribbon in the clipboard panel, I can select paste and do it align to same place and paste them in this design option. And then I can make modifications to this layout. Obviously right now I'm just doing a simple layout, which is probably not what would be done. It doesn't match a real world layout, but just to demonstrate the design options. And then you could switch back and forth between them. You could even use different types to show, once again, just to model varying lighting layouts. Okay, let's go back to the Design Options dialog, and I can do that by clicking Design Options in the status bar. Be aware that you can also, first off, we need to finish editing, so I'll click Finish Editing. And then if I wanted to, I could select an option and I could duplicate it. And then I'll also rename it, and we'll rename this one Option 4, and I'll click OK. And then we'll edit Option 4. And as you can see, that's another way to copy elements into another design option and then make modifications to those. Back on the Manage ribbon in the Design Options panel, you can also control the active design option. And if you wanted to add additional elements to your design option, you could deselect active only, and then I'll select another lighting fixture, and then we could add it to the design option set if we wanted it to be a part of the design option. So that's a high-level overview of design options, and typically they're not used much on the MEP side because of their lack of functionality with systems, but they may be needed to model lighting layouts for various design options that the architect may have. But if I go back to the Design Options dialog, I can select an option, and first I got to finish editing the option, and then I can select an option and I can make it the primary, and then in the option set I can accept the primary. And what this is going to do is, as you can see, it's deleting an option set and it's causing all of the secondary options and associated elements to be deleted. So I'll click yes and then click close, and now that design option becomes part of the main model. So once again, it's important that you know how to control it in a linked Revit model, and then it's also important that you understand the basic functionality of how design options work. In this video, we will cover transferring settings and types to other projects and copying and pasting system family types. When you start a new project in Revit, you base that project on a project template. Ideally, that template will have everything you need for the project. But oftentimes, you will need to transfer settings and system family types from other projects, or even other project templates. You can do that using the Transfer Project Standards tool. Let's take a look at how this works. To begin, let's create a new project. Click the File tab and then select New Project. We'll use the default Systems template and then click OK. In the new project, we'll open the 1-Power view, and then on the Manage ribbon, in the Settings panel, click Transfer Project Standards. This opens the Select Items to Copy dialog. The first thing you should do is select the project you are going to copy from. When you expand the drop-down, you can see any other project that is currently open in the current Revit session, along with any project that is linked to an open project or the existing project. In this case, we have an exercise file open, and that exercise file has a linked architectural model. That's why we see both of them here. Select the exercise file, and then you can scroll through the list to see all of the items that can be copied from an open project or project template. As you can see, there are various settings and several system family types. Remember, system families are defined in Revit projects. You can't open them in the family editor and load them into other projects. And so if you have system family types created in one project, you can then transfer them to another project using the Transfer Project Standards tool. For this example, click Check None so we don't copy everything, and then select Cable Tray Types. Additionally, select Cable Tray Settings and Conduit Settings. That way we can copy those settings from the electrical settings. And then once you have everything selected, click OK. And then depending on what you are copying, you may see a Duplicate Types dialog. In this case, it states that the following types already exist in the destination project, but are different. So we can choose what we want to do. We can either overwrite them, or we can choose to only copy the new types by selecting New Only. Or you can simply cancel the operation altogether. For this example, click Overwrite. Revit will then begin the transferring process, and once it finishes, you may also see some warnings. And in this case, we have 8 warnings. Anytime a warning appears, it's good to review it and take a look at what it says. In this case, we will scroll through the various warnings, and they are all pertaining to types being renamed. For example, type Standard has been renamed to Standard 2. So let's discuss this for a minute. I'm going to click in blank space to dismiss those warnings, and then I'll switch to the Systems ribbon, and in the electrical panel, I'll activate the Cable Tray tool. And with a type selected in the type selector, I'll click Edit Type, and then you can see various fittings that make up this cable tray type. And you need to remember that cable trays are system families, but the cable tray types are also comprised of several loadable families for all the bins and tees and transitions, and you can see all those here. So when you transfer a system family type, such as conduit or cable tray, it's also going to copy over those loadable families. And that's why it's renaming them. So I'll click Cancel, and then click Modify to end the command, and then let's scroll down in the project browser and expand Families, and then expand Cable Tray Fittings. And as you can see here, there are a couple or several of these families that have been renamed and appended 1 at the end of them. And you can also see that the type name has been updated as well. So that's why you get those warnings, because there are families that already exist in the project, and loadable families, that is. And so when you're transferring over the system family type, Revit is also copying over those loadable families. And so that's why it's renaming some of those when they are duplicates. Another way to copy system family types is to use the Copy to Clipboard and Paste from Clipboard tools. So when you're using the Transfer Project Standards, we're copying all of the types. But if you want to just copy one, you can do that as well. So I'll switch back to the exercise file, and then I'll zoom in and select a conduit. And then on the contextual ribbon, I'll click Copy to Clipboard. And then I'll switch back to the New Project, and then on the Modify ribbon in the Clipboard panel, I'll click Paste from Clipboard. And once again, we get a Duplicate Types dialog. This one is slightly different. It says the following types already exist but are different. And then it states that the types from the project into which you are pasting will be used. So I'll click OK, and then I will click to place the conduit and click Finish on the contextual ribbon. And then we can always come back and delete this conduit, because once we've pasted it, it has copied over the type. So once again, you can use transfer project standards, or you can copy and paste. And when you're dealing with system family types such as cable tray and conduit, you're also going to be bringing over the loadable families as well, because that's what makes up those types.